Welcome. Today we're going to learn about finding extrema on a closed interval. So let's begin with an example. In this particular case, we have a function, and our function is restricted to a closed interval between -1 and 3. So the question is, how do we find the extrema, which means how do we find the maximum and the minimum value of our function on this closed interval? So the way you should think of it is if you took a graph of this function, and we will show you that in a few seconds here, or minutes. If we have a graph of this function and we restrict our graph, only looking at the graph between x equals -1 and 3, then we want to say, okay, what is the highest point on that graph, or our maximum, and what is the lowest point, or our minimum? That's what we mean when we're looking for extrema within this closed interval. So let's begin with step 1. The first step is to solve for critical numbers. And I have a video that details the process for that. In our particular example, all we're going to need to do is to take the first derivative, set it equal to 0, and solve. In step 2, we want to evaluate those critical numbers, those x values that serve as critical numbers. We're going to plug them back into our function and determine what the y values are. In step 3, we are going to evaluate our endpoints. So in this particular case, our endpoints are -1 and 3. And so we are going to take those values, plug them back into our function, determine those y values. And then in step 4, the lowest value in steps 2 and 3 will be our minimum, and the highest value will be our maximum. So let's go through the process. Again, in step 1, you can see our function, and we're restricted between -1 and 3. In step 2, we take our first derivative using power rule, and we set that equal to 0. In step 3, we factor. Step 4, we solve for x. So x equals 0 and 2. Those are our two critical numbers. And you don't have to have 2. You could have more than that, but we have 2 in this case. In step 5, we evaluate our critical numbers. In other words, we plug 0 back into our function and solve, and we plug 2 back into our function and solve. And we get 0 and 16. Then in step 6, we want to evaluate our left endpoint, which is -1. We plug that back into our function and get 7. And in step 7, we evaluate our right endpoint. So we plug 3 back into our function and we get -81. Now below, I've set up a little table so that we can put all our values side by side and determine the highest and the lowest value. And you can see we've listed our left endpoint, critical number 1, critical number 2, right endpoint. We've determined all those y values, and we're really just looking at the y values. The highest one is, you can see in item 10, is 16. That's our max. And our lowest one is in item 11, and it's -81. So that is our minimum. And that is the answer to our question. So we're looking for extrema, and we've determined our max and min, and those would be our answer. Now the next step is to, this is not really a step, but I really wanted you to just see graphically what this looks like. So if we did graph this function, this is what you would see. And if you notice, I've kind of created a little barrier with my purple lines here between -1 and 3. So that you can see that we're only looking at our graph within -1 and 3. That's all we, between the purple lines basically. And that's what we mean by on a closed interval. And closed means that we do include the endpoints in our interval. So if you look at the graph, the highest value occurs at 1, if you, item 1, not x value 1. Item 1, our highest value there is, the y value there is at 16, which we already determined. The lowest value occurs at our endpoint, and that's at item number 2. If you notice, that's where our graph hits the lowest point, and it just happens to be at our right endpoint. Doesn't have to be, but that's what it is in our case. And the y value there was -81. So that's how you go about finding extrema on a closed interval. Now go practice, practice, and practice some more.